welcome back to another M&S tutoring video. Today we're going to be learning about parallel and perpendicular lines. So throughout the unit we've been learning about the equation of a line, converting between the two different forms, and also isolating for specifically the y variable to create an equation in the form of y is equal to mx plus b. But today we're going to be doing something completely different than what we've been usually have been doing, and we're going to be looking at parallel and perpendicular lines. Well, what are parallel and perpendicular lines? So first we're going to start off with parallel lines. In this case, they're lines on a graph, which you can see the y-axis and the x-axis, and we have line A and line B. Well, parallel lines are lines that never intersect, and this happens usually when they have the same standard, so that these two lines will never intersect. And the symbol for showing that two lines are parallel is usually by the arrow. So over here that you can see that there's an arrow over here and an arrow over here, showing us that both of these lines are in fact parallel and they will never intersect. Now, how can you tell if two lines are parallel given an equation? Well, say for example I gave you an equation. Well, this equation is not really specific to these two lines over here, but say for example I gave you the equation of y is equal to 3x plus 7, and I gave you the equation y is equal to 3x plus 4. Right? Say I gave you this equation. Well, what do you notice that's similar between these two equations? Well, of course, you'd say that the m variable, which in this case is the same, m, which is the slope, is the same in both equations, right? What this means is the slope of both lines is the same, and as we know, if the slope is the same as in both lines, the lines will never intersect, because if you're looking at it from a general standpoint, if both lines have the same slope, so say both lines run one and rise one, right? So this is line 1 right over here. And say line 2 is a bit under. Let's say line 2 starts from here. Well, let's say line 2 also has a slope of 1. So line 2 also, it runs 1 and it also rises 1, right? So we have our two lines being formed right over here, right? And as you can see, these lines will never intersect, because as one runs 1 and rises 1, the other one also runs 1 and rises 1, meaning that both the slope operations cancel each other out, making it so that both of these lines are parallel, right? So as we now know, for you to know that a line is parallel given the equation of a line, we have to first identify the slope. So a general rule for this is slope has to be, or is in fact, the same, right? When you're looking at two parallel lines. Well, now some of you may be asking, well, what about the y-intercept? Well, in this case, the y-intercept doesn't really matter. You can look at the y-intercept as basically just the starting value of the line, and with my previous example below, you can really see that the slope really has an impact on whether the line is parallel or not, and the y-intercept really has nothing to do with it. See, if you thought about the y-intercept of this line over here and the y-intercept of this line over here, and if both of these equations just had the same slope, it'd be running the same and rising the same, right? So it'd be running the same amount and it'd be rising the same amount. So let's say that this top line has a slope of 3, so let's say it ran 1 and it rose 3, right? And we'll say the bottom one, since it has the same slope, it ran 1 and it rose 3. Well, as you can see, as this line is progressively going up 3, this line is also going progressively up 3. As line B is running 1 and rising 3, line A is also running 1 and rising 3, making it so that both lines are going the same ways in the same speed, as you can look at the slope, making it so that both lines will be parallel, meaning that they'll never intersect. Now, moving on to the next type of line, let's look at perpendicular lines. Well, what are perpendicular lines? Well, perpendicular lines are two lines that intersect each other, right? And these are lines that intersect each other only at one point, of course. And as they intersect each other, they create a 90-degree angle, right? They create a 90-degree angle, right? That's what happens when they intersect. So we'll say that this line over here with my black arrows is line A, and this line over here with the blue arrows is line B, right? Let's say we have these two different lines, and we know that both of these lines are perpendicular as they intersect as a 90-degree angle. Well, how can we look at an equation and see if both these lines are perpendicular or not? Well, like I did before, I'll give you an equation where both the equations are of two perpendicular lines, not these lines, in fact, but just two perpendicular lines. I'll say y is equal to 2x plus 7, and over here I'll say y is equal to negative 1 over 2x minus 4, right? Well, what do you notice about these two lines? I'll give you a hint. It has something to do with the slope as well. So if you don't already know what's similar or what's different about these two equations, I'm gonna go ahead and just point it out for you. The m, right, for the two different lines is the negative reciprocal, right? Well, for some of you, that's a pretty big word, and you may not understand what that means right now, but it's fairly simple. A negative reciprocal is basically the opposite sign and the flipped fraction of this. So in this case, we have 2 as m, right? 2, and in this case, we have negative 1 over 2 as m, right? So if we really look at it, 2 is just basically what? It's 2 over 1. And we know that the negative reciprocal is just you basically flip the sign. So instead of a plus, you turn it into a minus, right? You turn it into a minus, and you flip the fraction, right, to get 1 over 2. And if you look at that, this negative 1 over 2 is the same slope for our second line over here, this line over here. Well, some of you may be asking, how can a line with a negative reciprocal, how can two lines with negative reciprocals really be perpendicular? Well, it's fairly simple when you think about it. If you have line A traveling from this point to this point, right? And you have line B traveling from this point to this point, right? I'm going to use blue for line B again and black for line A. And if you can tell, if this is a positive slope, if line A has a positive slope, say it's 1 again, right, as an example. If it goes 1 and 1, so right over here, and 1 and 1, right over here, 1 and 1, right over here. Sorry, let's make the other black dot over here, right over here, right? So this is the line, right? As you may notice, line A has a positive slope, whereas line B has a negative slope, right? Well, now some of you may be asking, why do you have to flip the reciprocal? Well, you basically flip the reciprocal because you want it to intersect at a 90-degree angle. Sure, if the fraction was just a negative fraction, sure, the lines would probably intersect, but they wouldn't intersect at a 90-degree angle. So when we flip this fraction of the other line, in this case line B, what we're basically doing is we're basically ensuring that it intersects at a 90-degree angle. So let's go negative 1 this time. So we'll go rise minus 1 and run 1 right over here. So run 1 and rise 1, boom, run 1 and rise 1, boom, run 1 and rise 1, boom, right? You have line A and line B right beside each other, so you can see it side by side, right? And as you can see, since line B had a negative reciprocal slope, it intersected at a 90-degree angle, which is exactly why you needed negative reciprocal slope for two different lines to intersect at a perpendicular, right? So overall, in general, the main point you should really understand in this is if you have two perpendicular lines, the slope is the same, and if you have two perpendicular lines, basically the slope is the negative reciprocal. Now, I'll give you a simple word problem. Say I have line A, right? I have line A. I know line A's equation. I know that the equation of line A is y is equal to, let's say, y is equal to 2x, let's say negative 2x plus 2, right? Say this is line A. Now, the information I'm given, I know that line B is perpendicular. So perpendicular, this is also another sign for perpendicular, to A, right? I know that. And I also know that line B intersects with line A at points, let's say 4 and negative 6. I'm trying to think of a point that would intersect 4 and negative 6, right? So now that I know that line B is perpendicular to line A, I know to use the sign flip reciprocal or the negative reciprocal. So I know that the general equation of line B would be just the sign flip reciprocal, which is y is equal to 1 over 2 x plus b. But I do not really know what b is yet because I really don't have enough information to solve for that yet. But I do remember that I have 2 points that fall on this line as it is a point of intersection. So what I will do in this case is I'll sub in y for negative 6 and, of course, x for 4. So if I sub that in, I would get negative 6 is equal to 1 over 2 times 4 plus b. And I would simply get negative 6 is equal to 2 plus b, and negative 6 minus 2 is equal to b, whereas b, or the y-intercept for line B, would be, in fact, negative 6 minus 2, which is negative 8. So now we know the equation of line B, which is y is equal to 1 over 2x plus b. There we go. So I hope you have a more clear understanding of parallel and perpendicular lines now, as I showed you a word problem, what perpendicular lines really are and how to figure out if two lines are perpendicular, and the general understanding for both parallel as well as perpendicular lines. So I hope you guys learned something new from this video, and thanks for watching, guys.